Okay, the attendees all coming through, fantastic. So, hello and welcome to the webinar, How Aerial Inspections and Predictive Maintenance are Revolutionizing Solar. Just to confirm and just check, 68 attendees already come through, fantastic, and that's going up. Can you guys all hear me just fine? Just write a little bit in the chat function just to say it's all coming through fine. Okay, looks good. Okay, and the attendees is going up. Okay, so I'm Luke Brett. I'm from Reuters Events. I'll be moderating this discussion. As you may know already, I'm organizing PV Operations Europe Conference March 5th to 6th in Munich. This is one of several pieces of work we're doing on utilizing digital tools to best manage solar parks. There are over 450 of you signed up today, so thanks very much for the great response. And thank you in advance to our panelists for their time. Just a brief bit of housekeeping. This webinar will be 60 minutes long and is being recorded, so we'll send you the full audio recordings within a week or so. You have the facility to ask questions through me as the moderator, so make sure you have access to your computer. The purpose of today's session is to take a closer look at aerial inspections and predictive analytics, tools that solar operators are focused on utilizing. Joining me today, addressing some of these key issues, is Nuno Marquez, founder of Aeroprotechnik, Felix Torres, PV O&M technician at Accionia, and Mikel Lopez, who is responsible for PV field and DC lines at Accionia. Everyone involved will be either attending or speaking at PV Operations Europe in March. So if you'd like to meet them in person and visit Aeroprotechnik's booth, then please do join us there by registering through our website. Just search PV Operations Europe and follow the links. Also, if you at any point want to ask the panelists a question, simply enter this through the toolbox and we will get it going during the Q&A sessions. So let's get our panelists to introduce themselves. Nuno, please may you say a little bit about yourself and your experience in operating solar parks.
Yeah, thank you, Luke, for your great introduction. Good morning, everyone. I'm Nuno Marques. I'm the founder of Aeroprotechnik. Thank you very much for attending this webinar. And we will do our best to make this 1 hour very useful and spendable at your time. I have more than 15 years experience in several domains of electrical engineering solutions, being that in the past 6 years, I've been very focused on driving Aeroprotechnik in this field of aerial thermographic inspection and predictive analytics solutions. Yeah, that's pretty much, my background.
Fantastic. And so, Felix, say a little bit about yourself.
Yeah, good morning, everybody. I'm Felix Balas, and we work in Acciona in the energy sector. So inside Acciona, we are in charge of giving technical support to Acciona's PV plant around the world. Right now, we are established in Spain, Portugal, South Africa, Chile, Mexico, Egypt, and Ukraine. The capacity we have installed in our PV plants is 1 gigawatt, and we have right now under construction 400 megawatts. We expect to have a rate of 500 megawatts per year, so we hope that by the end of 2021, we will be having 2 gigawatts. So as the technical support we give to our PV plants assets, it includes PV modules aerial inspections and predictive analytics. In that area, we work with Aeroprotechnik. He's our preferential partner in PV modules aerial inspections. We've been working together for several years, and that partnership and that collaboration led us to develop together the different tools that we are using right now. So we will have the chance to talk about them later on. And talking about PV modules drones inspection, Mikel Lopez, who is right here with me, he's Acciona's expert.
Yep. Go on then, Mikel. Do you say a bit about yourself then? Thanks for that introduction as well, Felix.
Yes. Hi, everybody. This is Mikel Lopez. First of all, I would like to thank Luke and Nuno for the opportunity to participate in this webinar. As Luke has introduced me initially, I work at Acciona Energy in PV production department, being responsible for PV fields and DC lines. Among these functions are all the work with Aeroprotechnik. We carry out an annual thermography campaign in each of our plants, coordinate with Aeroprotechnik to carry out this test at the time of the year that more radiation time exists, and thus facilitate the work. Once the tests are complete, they share the results obtained based on our indications about each project independently. So it will be a pleasure to share this time with all of you and answer any question you may have.
Fantastic, fantastic. Yeah, so to reiterate that, guys, do keep asking your questions. It's great to see just coming through on the text that everyone can hear everything nice and clearly. And so, well, obviously, we're keen to find out more about the content. So, Nuno, please do take it away and do your presentation on the given topic before we go into Q&A.
All right, perfect. So let's start. I will initially start with a presentation on how aerial thermographic inspections and predictive analytics are helping to revolutionize this solar industry, which is so demanding sector, as you know as better as me. So as well as demonstrate some of it to you, some of these analytics, which we believe will be very interesting and helpful for you. So let's start. I mean, the first slide, let me just move to the first one. I mean, this is just a little bit about history, just 2 seconds. You know, 500 years ago, there was already someone that saw the potential on the sun, and the focus is not just nowadays. It has been there since 500 years ago. So we have not been the first ones, but here we are now giving scale to it, right? That's why we are going to talk about the next topics. So all of this webinar will be based on how the aerial inspections and predictive analytics can help to do the things better, more efficiently, and at a lower cost. So that's really the drivers for the session and webinar of today. So we are talking about how to keep up efficiencies, how to boost efficiencies on our solar assets, how can we improve the quality and still be able to reduce the costs. So this is the big challenge that we are, and the main drivers to drive this revolution, because it is really a revolution. If you really look from what is the solar sector, this is a revolution on energy and the way we produce energy. So we believe that there are 3 basic and fundamental pillars to do that. So the first one is how to really boost and maximize the operational efficiency. So it's all about automated infrastructure inspection, but even more, how to scale it into the solar industry. And that's going to be one of our initial topics, and one of the, let's say, the first pillar to achieve these targets. The second one is once we have that automation in place, that scale when it comes to operational efficiency, how can we take the data intelligence into the equation and the key role of automate all the data processing and failure detection afterwards. So that's also a very important part of these new and innovative approaches. And the last one is about, once you have all of that data processed, characterized, and classified, how can you transform those data trends into real informed decisions? And that's when the predictive analytics came into place, right? So I'm going to address any one of these 3 points during the presentation, and by the end of my presentation, I will myself, together with my colleagues, answer any question you might have. So second slide is about the first pillar. So the first pillar is about how to maximize the operational efficiency. So we spoke about automated data collection and industry at scale, but how to do that, right? Because just automate data collection by itself is not enough. I mean, what we need in here is that we are talking about pretty much thermographic inspections. And when it comes to thermographic inspections, you have 2 main factors that you have to keep always in mind, which is first, how to keep the quality. Second one, how to scale it with that quality. So 2 very important points. The first one is the optimal incidence angle. So as some of you work in thermography, and you might understand, the measurement errors and the quality problems associated with thermography are typically caused by or too shallow incidence angles or reflections in the solar panel. So you need to make sure that every single thermography you capture is having the best trade-off between maximizing emissivity, yeah, and avoiding completely reflections. So there is a window of optimization that is very important to work on in order to have every single thermography as sharp as possible, as good as possible, in order to detect even small differences and do not have any type of inaccuracy. So we are talking about dynamic flight plans that adapt along the day. They take in consideration terrain models, they take in consideration solar maps, and every single thermography is captured in an optimized way. So that's extremely important. It leads us, and we believe that's one of the main pillars. It can lead us to improve defect detection and accurate measurements. The second one is about individual infrared captures, which is every single thermographic capture should be unique and optimized on its incidence angle. Okay, so for that is essential as well to bring into the equation geolocator algorithms that are able to geolocate down to the PV module ID every single thermography, not relying on orthothermal photo reconstruction techniques, because that would not take care of incidence angles. So it's very important geolocator algorithms in this type of field in order to optimize incidence angles. The result is higher thermal resolution because you don't need eye overlapping. You need little to no overlapping, so you can really fly and collect the data much closer from the thermal modules. And it gives you another thing, which is scale. You really can scale up. So that's the biggest, and in our opinion, the two main factors that can really maximize operational efficiency at scale. So the next one, and even before I go to the next one, I would like to show you something I believe is very important. I mean, let me show you, for example, example of a proper incidence angle. So let's go, for example, for PID. Okay, PID defects. I'm gonna go for one PID defect, and I'm gonna go open it. So on the right side, if you can see this screen, this platform, on the right side, you have the thermography in black and white. You have the geolocation algorithm, so you can see all the geolocated module IDs in here. And you see small patterns, very tiny patterns in this thermographic capture on the right side. And this one in platform is not full resolution. This is really higher resolution thermography. Even small differences, small thermal patterns are detected. And this is very important because, for example, PID in early stage is very difficult to identify. It's tiny things. You need to correlate a lot of information. You really need to see these tiny differences. So that's only can be achievable when you really have optimal incidence angle. And that's a very powerful, I guess, way to really do it, and very important one actually. So the next one is about the key role of data intelligence. Solving the problem of data handling, how to automate the data processing, the failure detection, and what is really the real benefit on doing it, right? So we spoke about collecting data with the proper incidence angle, with maximized emissivity, with no reflections, very sharp pictures, not much overlapping because we don't need it. We can rely on geolocation algorithms, and that gives scale to the process. So that's fine. Now, since we have all of this amount of data, we need to process it. So there are two very important modules before we go to predictive analytics in order to scale it up. So the first one is the geolocation algorithms. So you need to precisely identify every module ID, right? But at the same time, you need to rely on unique thermal pictures. That means, you know, it's if you really want optimized angles, then you have individual pictures, individual thermographies that are treated separately, every single one of them with the proper incidence angle. So what we need, precise geolocation module to give massive scale to the solution. So advanced geolocation algorithms, we believe, will play an important role in the sector. So they typically might take in consideration terrain models, layout of the plant, metadata, and all of that in a geolocation engine that gives you goes down to the PV module ID and gives you really perfect geolocation at scale. And this is important, at scale with proper and optimized thermographies. Second one is automated failure detection algorithms. Yeah. So you have to detect the defects, but you also have to characterize them and root cause them. And this can be done automatically, of course, with a lot of development and algorithm, but it's possible to do. It actually is very accurate, and gives you a lot of scale. But there is one thing that is even more important than the two previous ones that I mentioned, which is, keeping always the same criteria when you classify defects, when you identify, when you characterize them. So you have consistency. And that consistency will allow you over time to make your analytics much more accurate. So you can really rely on the data, on the analysis that has been done, because you have no human errors, you have no interpretation deviations. What you have is a very consistent classification, characterization, and with that, you can really work towards the predictive analytics, which is going to be our next topic. Okay, so let's go now to the predictive analytics. I think everyone is looking for it, including myself. So predictive analytics. At the end of the day, in here, what we are looking at is, what we believe is the way to transform these data trends into informed decisions. That means, how can we, optimize CAPEX, optimize OPEX? Two different things that can be done with predictive analytics. So how can we, for example, optimize interventions in my plants? How can I mitigate the production losses? Where should I focus first? So all of these optimizations, how in advance can I claim a module? How in advance can I realize that I will have a problem or a massive problem in my type of modules? All of that is what we are going to now show you with predictive analytics. This is going to be just one example. There is many other things we can do with it. This is just one example. So predictive analytics, there is three main things, very important. One, the first one is to follow up and root cause degradations over time. The second one is trend identification. And the third one, and also very important, is you might have the trends, you might have identified your problems, the root cause, why them, even in advance, upcoming problems. But now you need to quantify what is your production losses, right? To have estimation at least on how is going to be your production losses, so you can make your own priorities. You can understand, how I capitalize my inspections, what is my return of investment if I do this or that, and so on. So it results in advanced predictive maintenance capabilities, which can lead you to optimize the energy yields and really look at predictive behaviors and upcoming defect identification. That's very important. So said that, let's go for the next one, which is going to be, again, back to the platform. I would like to show you three ways of doing predictive analytics, or three predictive analytics, but many more can be done. Yeah, this is just an example. Okay, let's start with the first one. So this is like a global predictive, some data correlations that by itself are already very powerful. So let's imagine, for example, that you have all your defects in your plants, you have all your classifications, you have, all your characterizations in terms of defects, and you are classifying them if they are major, if they are medium, or minor criticality, all of that, right? But now that's by itself, it's important, right, in isolated mode. But when you have to manage a high portfolio or big solar farms, you need to understand what's really causing the things, why, when, and try to mitigate them in advance. So let's take again the example of PID. So in this chart in here, you can see on your left bottom side, you have several types of problems and the affectance on your assets. So let's click, for example, on PID. If you click on PID, what you will see is that PID represents almost 50% of the major defects, and the PID is essentially happening in the module type F, to say a name. 82% is in module type F. So this analytic tells you straight away that I have PID in my farms, and 82% of them happen in module number F. I have some other modules with PID problems, but the affectance is lower. And if you look at the right side of the picture, there is an analytical correlation with years of operation, which means these red bars is PID. And if you can see, is essentially after the 4th or 5th year of operation, for this case, that the PID starts to appear in your modules number F, which means you already know, that after 4 to 5 years of operation, most likely farms in the same situation with same type of modules in same geographies, they will actually get PID. So now imagine that you say, okay, that's good. I mean, I have a good insight. So I have, 10, 20, 30 megawatts, doesn't matter with this type of modules. I know that the farms are quite young, but from my trending and my forecast and analytical forecast, I know that they will get PID quite soon. So you can act in advance, right? You can do many things. Many customers are doing it already, acting in advance in situations like this one. But you can even do the thing in the opposite way, which means, you want for a type of module and you say, but what is the dominant problem in this type of modules? You click in the module, for example, this one, and you see that, again, the PID is the worst case, but you have DBD problems and others not related with the module. So you might say, all right, this module is affected by PID. And the other problems are not really related with module. But if you go to another type of module, the setup changed completely. For example, the module type N is a module that typically is having a lot of internal cell damages and over time starts to have cell mismatching more than the others. And this is also very important to understand in your footprint. So this is one of the ways to really root cause the things. You can even go and say, all right, I want to analyze just my measure and see what are my major problems in my footprint and after how many years it happens. So if you look at all the measures, you get that PID represents 40% of them, non-functional modules 23%. I have some 20-something% open strings, 8% is DBDs, and then I have the cell mismatchings and the other type of issues. And I can see that modules type A and K are quite good contributors after the module app. So, and I even can see after how many years it happens. So this is very, very, very powerful. Anyways, this is root cause, right? There is even other ways that complement this analysis. Let's say, for example, the predictive over time. So what I'm going to do in here is that I'm going to select a period of time. Okay, in this case, I'm going to select from 2017 to 2019. And I mean, we could select, whatever period of time we want. The important thing in here is I want to understand, I already know that I have a problem. I identify my problem. Now I want to understand how it degrades over time. I want to understand how quick I have to be in acting in my network, in my footprint in order to fix it. So since we have been speaking a lot about PID, and PID, I think everyone agree that PID is a critical issue in solar farms. So in here on the left side, you could follow up types of defects over time. Okay, for example, you have options to select, modules that were having no problems, and now they become PID, for example. So if you select these cases, you can see straight away that between 2017 and 2019, 9,040 modules have been affected by PID. So 9,000 modules that were very healthy, now they are PID affected. So this is a good insight. You can even see the type of modules affected over these 2 years over this 2 years period, and you can see even the delta of temperature caused in the spots of the PID. It also can give, it doesn't look too relevant, but it can give really good insights as well on the degradation over time. But you can do other things. You can even look at, how many PID modules you have recovered, for example. PID to known, that means I was having PID in my farms. Now I have 9,600 that were having PID and are fixed. Why fixed? Because I'm doing things, right? I'm acting in advance. There is several techniques. Maybe I put PID boxes. Maybe I'm grounding the inverters if I can, whatever to recover my PID. So I see I can also track the amount of things that I can recover. I can even do the ratio between the number of new modules with PID slash the number of modules that I can fix over time, that I can revert the effect. And that's another very important thing, because I can really see if I'm going the good trend or in the right, in the good or the bad trend of the thing, right? The next one is, all right, all of this is very nice. You can see over time and so on, but you can even go further. You can even say between 2017 and 2018, I want to analyze just what was no problem to measure, because that's what really affect me. That's what really will hurt on my myself. That's what even financially can affect me, right? So you can, aggregate the data by critical known to measure. You just click in here in known to measure, and straight away what you have that for between 2017 and 19, the worst thing that happened was from very healthy type of footprint, I got a lot of open strings, for example. From the second reason is PID. I got a lot of new PID affected modules. And the third is DVDs, right? So I got three main things that I need to focus on. Open strings, typically is a quick win, is quick to fix. Then I have the PID, is a little bit more complicated, but still in early stage is possible to revert. And then I have the DVDs, which is as well a problem that can be fixable. And I can act in advance. I can even see the modules that are affected by this one in detail. Yeah. And the last one, and to finalize the analytics that I was planning to show to you is about estimated impact on installed power. That means, I mean, we spoke about what defects, why they degrade, after how many years they become critical to me, which ones I should focus first, what is quick wins or not. Quick win usually is something that you with less effort you can really bring a lot of benefits. So it's very important now to understand the impact on installed power, on available power, so that you can really prioritize your things, and even more important, you can calculate the way you can monetize the things. You can really optimize things. So let's, for example, in this case, there is about 18 megawatts unavailable. Yeah, 18 megawatts unavailable. So if you look at the chart, this kind of box analytical chart, you got like 68% of the estimated impact. It's coming because of open strings. 9.4 something is because of PID. some 4%, 5% on dirtiness in some modules. Vegetation creating shadow in the modules is affecting as well in a certain good extent. Then DBDs and cracks as the last ones. So if we go now and if we say, all right, all of this is very good, but I want to go for quick wins. So I want to really fix my open strings as a first instance. So you can click on open strings, okay? And straight away what you have is that for open strings, if you fix it, you straight away would get 12.5 megawatts available, and majority of cases are in a certain farm, and the farm is highlighted in here, okay? So this is very, very important because these analytics and the way you can correlate defects, evolution, criticality, plus impact or estimated impact in my installed power can really take it to the next level, which is not just about now operation and maintenance or OPEX and CAPEX optimization. It's also about capitalizing what you are doing. Is about proving that you are capitalizing the things. It's about, you know, estimating and take decisions in the trade-off between investment and return of investment. And this is something that we have been doing quite seriously, because we believe it's going to be, it's already extremely important to many operators in the sector. But I can, I can say, okay, since I have to go to the farm 1086, just to say a number, if I can go to a specific farm and I click in that farm, since I have to go there and fix the open strings, what else I have there, right? And you can see that open strings is 88% in this farm of affectance, not 88% of strings affected, but 88% of the 7.5 megawatts not available are due open strings. That's what it means. But I have also some dirtiness in the modules, and I have some DBDs that I could fix. So why not prepare for that straight away, so I don't have to go there twice? Or for example, I want to do a campaign, and I want to understand from vegetation point of view which are my worst farms. So I can see that in here there is no dominant farm in this sense. So it's something that I need to take more globally, understand better globally why my vegetation management is not working so well, right? But if it is PID, you click in PID, and straight away you have dominant farms. So you have farms affected by PID. You pick up the one that most affect you and say, why not to start by this one? Because in one single go, I can maybe install a few PID recovery boxes that I have in house, and start to recover these modules, and let's see in 6 months how is it. So all of these ways to correlate technical predictives, forecasts, and estimated on and impacts on footprint are very, very powerful in the way that we do predictive maintenance, but essentially in the way we can start to do a lot of new and implement a lot of new advanced techniques to optimize CAPEX and essentially OPEX in your assets. And pretty much that's all I was planning to show you. Just one last slide. I think it's important to mention. I don't want to make this slide commercial. That's not the aim of this webinar. I believe it's worth to be mentioned, because it's not really just a prototype. These techniques have been well proved and tested globally. More than 25 million modules inspected, more than 500 farms, 6 gigawatts inspected, another 6 in pipeline. And a lot of people in the sector is already using some predictive analytics. The good thing in here is that predictive analytics are endless of possibilities, and when we start to work on it every month, every day, we have new things that we can see, we can implement, and we can actually profit out of it. So thank you very much. That was my main presentation. I officially opened the Q&A session. Feel free to address us any questions you might see relevant. Thank you very much.
Perfect. Thanks a lot, Nuno. I think we all agree that gave a really good rundown of absolutely, well, almost everything aerial inspection focused. I'm just going to ask a couple of the questions we had kind of prepared beforehand, and of course, encouraging you all to keep submitting your questions. We've got some really good ones coming in, and yes, we will be sending the recordings afterwards. But I want to get the Axonia guys in, quickly ask them. Big data and predictive analytics are mentioned nowadays in many industry sectors, but how exactly are Axonia getting an advantage out of it? Obviously, you're partnering with Aeroprotechnik, but what are the direct efficiencies out of these data analytics?
Well, it allows us to follow up degradations, understand trends, and be aware of defects that are about to affect our production, as well as upcoming ones. So this way, we can act in advance, avoiding any losses of productions.
Perfect. And from a OPEX or CAPEX point of view, how do you, monetize a service like Aeroprotechnik?
Well, thanks for the question. Look, I mean, first of all, when we drone inspections that led us to thermography all the PV models in a very short period, So if ever we find hotspots or DVD defects or major defects or whatever, we can directly do a claim to our PV models manufacturer. So that's a straightforward consequence from module thermography, And as we can use drones and aerial inspection for the thermography in a very short period of time, that led us also to make an inspection once a year, So as we are doing the inspection every year, that led us also to have a track record of the state of the modules and see how they are, how is the evolution over the time, So we know how they are evolution, how they evolve the state of the models. During the time, and we can also compare them with other PV plants all around the world, so we can see how they correlate the defects we find with other factors like geography or local O&M practices, weather conditions, type of modules. I don't know, a lot of them. Type of modules, the manufacturers, so we can see if there is any difference between different manufacturers of modules. So just to answer your question, in general, like in the short term, the PV modules inspection gives us some information in order to take decisions in maintenance, like guarantee claims, frequency maintenance, required maintenance, etc. And in the midterm, like in CAPEX, we have the information, so we know how is the performance of our modules, so we can have some failure rates, we can fix our stock, we have more liability, we can reduce our risks. So in terms of CAPEX, that makes a lot of savings also, So our OPEX model CAPEX is much better when we have that information on how the modules they perform.
Absolutely. Well, obviously this ties into operational efficiency. So, Nuno, I want to ask you what the key factors behind this is. Is it drone technology?
The drone technology. The drone itself is a great technology, but it represents a tool for us. It allows us, of course, to automate the data collection workflows. However, I have to say that it is the integration and the correlation between the flight data collection algorithms and mostly when we talk about adaptive flight plans that at every moment adapt to the proper and optimal incidence angles, that really, and geolocation algorithms that integrated together bring the scale to the process. That's really what is the main difference. But for sure, the drone technology itself and more is becoming very important as it becomes also more open source and we can do more things on top of it. But is that integration between the AI layer of optimizing the data collection when it comes to incidence angles, adaptive flight plans that we have in algorithms and that have been developed over time with a lot of experience in the plants around the world, that really makes that huge difference and brings this quality at scale, which is very important, this quality at scale into the process.
Well, there's a kind of ties in as well. There's a question from Lewis. Says, have you how have you calculated the performance increases on application of the techniques that you were speaking about?
Yeah, the impacts and the estimations, and if you go back to the dashboard, you can see that it's a estimated effect footprint is an estimation, is a good indicator, and that has been done because we have characterized every single defect. We have forecasted upstream into at string level and understand the impacts it causes in your footprint. So then what we can do is that we can use that information to then basically calculate and have some estimations on an available footprint. That's the way we do it.
Fantastic. And also, you're talking about collecting all this data. It's what we kind of do with this data that really matters. So there's a question for Axonia from Avner. He says, have you been able to use this data successfully in warranty claims? Has it worked with predictive data?
Yeah, absolutely. Actually, what we have developed with Aeroprotechnik is that the results of the thermography, they are delivered in a format or in a type of document which we can use directly to make a claim to the PV module manufacturers. I mean, we have different reports. One of them is in order to have the information inside the company, so we can analyze and take some decisions. And there is another kind of report which is automatically done by Aeroprotechnik that help us to make directly the claim to the manufacturer. And so far, it's working fine.
Perfect. And well, I suppose I wanted to ask Nuno as well. As the assets grow more and more in size, it's essential for these solutions to become very scalable and cost efficient, I'm sure. So how do you and Aeroprotechnik face this reality? And it ties into a lot of questions being asked by the audience.
Yeah, that's the key point on it, right? I think everyone knows very well solar is an industry at scale, and as such, it needs to grow up quickly and grow up in size. They grow up in costs, or grow down in costs. So I think the key factors, and in here we are talking about automation and AI, artificial intelligence. I mean, both things. This combination is really boosts efficiencies and reduce the costs everywhere. So automation, not just in this sector. I mean, it has been actually used in other sectors from quite long before we start to do it in solar. But the automation allows us to do more quicker and becoming more efficient, avoiding human errors. That's for sure important. And then the artificial intelligence brings also, this layer of classification, quantification, trending, recording over time with unprecedented levels of consistency. And all of it together allow us to then give us the next step, which is the predictive analytics to really take and monetize these things. So in conclusion, I would say the key factors in here are called two words: automation and artificial intelligence, for sure.
Absolutely. And well, a question I'm going to ask both of you. I'll start with Axonia, and then we'll ask Nuno to respond. There's a question from Hugo. He says, what is the ratio between the cost of carrying out inspections and the gains obtained from the improvement made? Can you get any kind of idea? We'll start with Felix and Michael on that, and then Nuno, we'll get you to add your comments.
Yeah, well, I think it's a very difficult question because there is some benefits. It's difficult to monetize. I mean, like to know the information on how your PV plant is performing, or like it's going to let you know, like in a future PV plant, how what you expect of the PV plant. So it gives you information. It's difficult to give a straightforward answer. What we can say is that that gives us a lot of security. We can correlate the algorithms we have in our PV plants with the results of the thermography, so we are sure that we are performing the PV plant as it should be. We're operating the PV plant in the best way. So yeah, I think it's going, and also it depends a lot. It changes a lot from one PV plant to another. So I will say more than a straightforward answer is more than a I know how to say, like in a way to be sure you are operating your PV plant in the best way and you are not losing any kilowatt hour. And that's another tool. The area special is another tool that gives us that security and give us comfort.
Yeah,
I don't know if Nuno, you agree with us, or like maybe you have a different.
For sure, we are more than aligned. I mean, I just have to say that, as you said, and it's very important, from plant to plant it depends. I mean, the ratio is not constant. The way we can monetize the thing is slightly different. I can give you a few examples, just as examples, but it might be completely different. I mean, if you really act in advance, and it happened with one of our customers. If you really act in advance in a plant where you know that you are going to have PID issues, and if you can predict that in 3 years timeline you are going to have X amount of footprint that is going to be affected, and the affectance is estimated to be X value, even if the accuracy of that estimation is good enough, okay, we don't have to go to of course, forecasts are forecasts, and everyone knows it, right? Algorithms are algorithms, predictives are predictives, they are very good, but there is always a small level of deviation from it. But in here, what we are talking about is to really understand the things inside the comfort zone, and based on that, go and estimate the things. And I can tell you that in this case, easy, you might be talking about, the cost of the service versus your benefit might be, fold of 10, easy, or well, as minimum. So it's not really. I mean, we cannot. That question cannot be seen as globally, because every plant, every problem is going to be different. Of course, I mean, let me give you another example. If we have a plant that we inspect and there is nothing, there is no problems at all, right? At least from the thermographic footprint point of view. So then, I mean, you would say, I mean, I lost this money, right? But it's not really like that. When we look at the huge footprint and want to do the things at scale, and you want to really understand the things and mitigate the risks and everything, we can have estimations about the return of investment that in one plant can be 100 times, in other plant can be just 2 times, in other plant can be 3. I mean, it really depends on the plant by plant. But what Felix said is very true. I mean, all of these techniques, as they get more and more integrated into the day-by-day activities and into the way we operate the footprints, they become more and more effective. And that's really I think the biggest message. Now, if it is, the cost benefit is positive, for sure it is positive. I mean, otherwise no one would do it. And we have been seen, we have numbers in house that of course reflect that. It's very important to mention it.
Actually, I think you have to take into account that nowadays the PV plants they are bigger and bigger. So like we are talking about PV plants, the smallest one, they might be about, 50 megawatts, and that can be up to, 200 or 400 megawatts. So if you want to take the thermography of each PV module, there's no way you can do it by hand, because it's going to take a lot of time, a lot of effort, and it's going to be very difficult to analyze. Now we are talking that, for example, a plant of 240 megawatts, we are able to thermography all the PV modules, analyze them in 2 weeks, So sometimes it's not just a matter of monetize. It's just a matter that there is no other way to know how your models are performing and to know if they are performing as is expected under the contract. There's no other way to do that unless you use I don't know, like the new technologies nowadays are available as aerial inspections, So whenever, if there is no defect, so at least you know that your PV models are performing well, so you have no defect in the PV field, because it helps you not only to check the PV models, but it only helps you to check if you have any defect on the cables, on the connectors, or maybe in the whole PV field, So as I was saying, if there is no defect, at least you know that you don't have any defects. So maybe you can take the decision not to thermography the PV plant every year, but maybe twice a year, or maybe, I don't know. That is going to help you to take decisions in the maintenance. And if ever you have defects, well, that is going to help you out to make a claim to the manufacturer, and then you can monetize the money you spend on the thermography. You're going to get it back from the guarantee of the manufacturer of the PV module. So I know, I think we have to see it more in that way of practicity, and the only way to verify the state of a very big PV plant is to use these kind of technologies we have available nowadays.
Absolutely. I mean, well, with this data then, a question from Colin. The data collected during a drone fly, is it sufficient for the predictive for adding to predictive maintenance, or do you also need to access the plant's meteo data? Who wants to kind of answer that? Nuno, do you want to add a comment, and then Axonia too?
I can start. Just as a matter of example, all the predictives I have shown today, they are possible to produce only with thermographic data. However, we have been correlating thermographic data with other sources of information to get further insights. But I think that's the good and the beauty things of the analytics, which is, once you have the engine and the setup, working, then you can actually correlate any type of information. We have done it with geographical information, with weather conditions, even data coming from SCADA systems. We could correlate it. It's just a question of integrated, and the integration is quite seamless. Yes.
Perfect. And Michael and Felix, do you have any comments on that question?
Well, yeah, I agree pretty much on what Nuno said. Just to be clear, aerial inspections is one of the maintenance we can do, or the inspections we can do to the modules. But there are others we are also implementing, as electroluminescence, or recording or performing the IV curve of the module, the power of each one, to see if there is any evolution of it, any decrease. So yeah, I think there are complementary inspections or test performance that you can do in order to check the state of your PV field.
Oh, perfect. So another question we will go into is, how much data can you detect basically from these aerial inspections, and how in depth can it be? I know you obviously went into a lot, Nuno, but Edison asks, how much data of the specific PV plants do you need to classify defects? So yeah, do you want to make a comment on that, and then Mike and Felix also add something?
Let me see if I understood the question. So is how many data, what does it really mean? I mean, how long does it take to collect the data? What's specifically the question? Sorry.
It was just kind of how much data do you need to classify the defects? I mean, just from the aerial inspections alone.
Okay. Yeah, I mean, in here there is two or 3 points that I think it's worth to be mentioned. Is that the PV footprint, when it comes to thermographic inspection, is much more than just hotspots, right? Is to the way you can characterize the hotspots. There is about, I mean, at least it comes to my mind about almost 20 different type of defects that you can classify with the thermographic data. And in order to be able to do so, you need, as mentioned at the beginning of this presentation, you need really high quality data, because some of these defects, they really affect a lot your footprint, like the PID, but the patterns are so tiny, and you have to correlate not just the thermographic data, but you need to have information as well, which we do about the electrical connections in your strings, so you can correlate the PID patterns with the electrical connections, and so on and so on. So all of these data, in order to be able to really go into this deep detail and classify this huge amount, this list of very extended list of defects, which are very important to be aware of, you really need to have high resolution at thermal pixel level. Otherwise, two hotspots, they might look similar, but in reality, they are different type of defects. So in order to do that, you need to really go into high precision data. Every thermographic picture should be with optimized angle. The thermal pixel should be very, very, very low. That means you need to really have high resolution to do it. So if that's I mean, when it comes to answer that question, that's what we say all the times. I mean, every picture is a unique picture taken picture. I mean, thermography. Every thermography is unique with proper incidence angle and with a very high resolution that usually is about 2 to 2.5 centimeters at ground level at least. So and that's very important. So that results in, of course, some amount of data per farm. But another thing that is very important was mentioned as well during this beginning of the webinar is that since we believe that the best techniques is to rely on geolocation algorithms to allow you to optimize incidence angles, you actually don't need to go to techniques that are not really related with thermography, like if it was a land survey, doing thermal orthophotos, which is not thermography, right? And requires a lot of effort on the field. What really we believe should be done is different, is a geolocation algorithm. Every picture is unique, little overlapping or little to no overlapping from thermographic inspection to thermographic inspection, which really brings two things very important. One is allows you to fly much closer with the modules, and as such optimize much better your incidence angle and getting a better quality and resolution. And second thing is that with your geolocation algorithm, you are able to detect and go down to every PV module ID, and doing it in this way, it is highly scalable. That's why usually in very large solar farms with the new and concentrated solar farms, I mean, one team per day can go up to 50 to 60 megawatts. It's really scalable. Yeah.
Okay, and related with the last question for Luke, and when he asked about the size, for example, I want to give the data about one plant that we have about 240 megawatts peak, and all the results that Aeroprotechnik give us, they are around 120 gigabytes, and it also depends about the structure, if it's fixed or it's a tracking structure. This case is a fixed structure. For example, for another kind of tracking model, maybe it's different. And it's just to give a small example about one of their jobs.
Yeah, just adding to that, I mean, it's that the huge size of data is coming from high resolution pictures, pretty much.
Yeah. Well, obviously I know we're close to wrapping up, but before we do, I just wanted to ask all the panelists. I know Axonia were one of the first to implement large-scale aerial thermal inspections. So I'd like to ask them to give us 3 takeaways from what they've learned from them, and then Nuno also a couple of takeaways from what you've learned from your aerial inspection solutions and predictive diagnosis.
Yeah, go ahead, Felix, please.
Okay. Yes, the first one is the automation operational efficiency translate into consistently of results of year after year, which is the key for a trend detection. It also gives us information which we can check the operation status of some of our algorithms. And another one, analytics leading us the insight and inform business decisions. And finally, relate that Felix has commented before, thanks of this aerial inspection, we can get a direct capitalization for OPEX and CAPEX optimization.
Yeah, I think Mike, you have said absolutely everything. I mean, I would just add a small thing in here, which is the automation, and I would like to stress the automation point. I mean, AI is very powerful and everything, but being able to automate workflows has been in many sectors of electrical engineering, not just in the solar, a key step forward to create efficiencies, to reduce costs, to create consistency over time, and to really take the thing to another way. And to do that, it's a working, it's a common work, and actually we need. We as Aeroprotechnik are very, very, very happy to team up with companies like Acciona, because we really are able to to in a very open way to work together in these new techniques and really fine tune them to bring them at scale to the footprints and take profit of them. So I would finalize my intervention by saying that automation, leading and operational efficiency is the key, and together this binomial of automation leading to operational efficiency and predictive analytics is really the future of the way we do one of the features of the way we do solar, and one of the things that can help to revolutionize and take this sector forward. From my side, I'm very happy with this webinar, and I'm very grateful for everyone that has been attending it. So thank you very much.
Absolutely. I'd like to reiterate that, and thank you, of course, to Nuno, Felix, and Mikel. Nuno, excellent presentation. Great questions from the audience. Great feedback from Felix and Mikel. I'm sure you found their insight useful, stimulating, and certainly food for thought. You can see Nuno's email there if you obviously have any questions to follow up with. And if you will have full access to the audio replay within maximum a week, hopefully by the end of today. Please do share these with your colleagues, your clients, the broader solar community. The aim of these discussions is to get more operational change in the solar industry and get more conversations going on how we can improve managing these plants. So that's all. Thank you all ever so much for tuning in. Hope to see you at PV Operations Europe next month. And thanks again. Bye-bye.
Thank you very much, everyone.
Thank you. Bye.